So yes, we are being recorded. So let's start out with some roll, and then I'll go back because I got a feeling there will be people joining us. Oh, I did fill that out. God dang it. I'm so glad. I was thinking I didn't need to go back to my house to print a new roster, but I actually did need to go back to my house. And I did go back to my house and print a new roster. Dario. Jesus Barreto.
I'm here. Good morning.
Good morning. Glad to see you, Jesus. Donna Davis. Armando. Mundo.
I'm here.
Emmanuel Gutierrez. Manny. Brenda and Jose. Coming to you all the way from Hesperia, California. Catherine LeMay. That's odd. Colby. Hugo.
Yep. Hi.
Hi. Kevin Nolasco, hopefully will make it late. I'm going to give him an E because he's having trouble with his router, replacing the router. Eric Garcia Mendez. Eric. D'Angelo Rangel. Josh Santana. John Stesser.
Here.
Michael Silva.
Here.
Jose Nunez Silva.
Here.
Aurelio Uribe.
Here.
Dennis Vega. All right, so if any of you, because you can see the screen tiles how I can right now. You see somebody pop in here and they go, oh, that guy wasn't here or girl wasn't here. Unmute yourself and speak up and tell me, please. Tell me what's happening. So since I saw you last, I got my first vaccine, my first dose of the vaccine. I'm gonna turn some lights down here. It's too bright. That's more energy efficient too. That's pretty good. Okay, so yeah, I got my first vaccine. It was a piece of cake. Anybody else here get vaccines? Anybody else old enough? Brenda, you got one? Brenda, Jose, you guys got your first ones? Cool. I was pretty impressed the way they had it laid out at Cottage Valley, Goleta Valley Cottage. You never got out of your car. Just stick your arm out the window. It was pretty good and pretty efficient and friendly. And, my arm hurt like heck for a couple of days, but hopefully I won't get it. And then with any luck at all, I won't give it to anybody else if I did get it.
My daughter's arm and my arm hurt too.
And arms.
Yeah. Even to lift it was like,
Yeah.
Yeah.
It's
Our pharmacist, a bunch of people canceled on him, so he started calling people so he wouldn't have to dispose of it. So we all went.
Good for your pharmacist. Speaking of pharmacists, on the way here, I was listening. I pretty much listen to NPR, and that's partly because I can't find a place in my vehicle to put a satellite, to put the little thing. And I just haven't taken the time to learn how to, because my phone would play music, but maybe I'll ask somebody young to show me how to do that. But anyway, I listened to NPR, and I was listening to NPR this morning in Minneapolis, Minnesota. The trial for the police officer that killed George Floyd, it starts on Monday. So they were interviewing this guy, the owner of Seward Pharmacy, he is an Ethiopian man, and his pharmacy was burned to the ground, looted and burned to the ground with that second night, when the riots were happening and things were getting pretty bad. When that incident happened with George Floyd, and it was pretty interesting interview with the guy, because they were pretty devastated when they came that next morning and saw their, this pharmacy basically not burned to the ground, but just, medicines everywhere and ashes and water. And the place was completely 100% destroyed on the inside. They were very discouraged, and it felt like they couldn't go on. And then as the morning wore on, neighbors started appearing. I mean, virtually by the end of the day, the whole neighborhood had come to this guy's pharmacy, and they had cleaned it up, man. The neighborhood got together and helped the business get back on their feet, which is what it's all about, if you ask me. And in that vein, well, I'm going to read you
That's
something
awesome.
from. Say again, please.
I said, that's awesome.
Yeah, isn't it? And I'm going to read you something from the Four Agreements, but before I do that, I'm going to take roll, which I did. Anybody show up? Let's see. Dennis showed up. Since
Yeah,
I
I'm
took
here.
roll. Josh showed up.
Yeah, here.
Took roll. Gotcha. D, did you show up? D'Angelo, Eric Mendez, Catherine LeMay, or Jose Landeros, Emmanuel Gutierrez.
Yeah, Jose's here.
Oh, yeah, Jose and Brenda, I got you guys. What did I say? I'm sorry, I'm just reading. Emmanuel Gutierrez, Manny, Donna, Dario. Okay. Hey, all right. So do a show of hands. Do any of you are any of you familiar with this brand new Back to Work BTW program that City College is advertising and coming out with, and is created and starts the 15th next week, a week from Monday? Anybody? Raise your hand or say, yes, I know about it. Okay. John knows about it. Well, I'm going to tell you about it. And I can go, well, actually, I show you the banner. I'll show you the stuff that's come out in the news media when we go into my screen sharing, because I want to show you something that I emailed myself. So, but I'll tell you what it is in a nutshell, is that the School of Extended Learning here, that non-credit part of City College, here at the Wake Center, for the most part, has put together this Back to Work program, and they've got 5 trades. We are one of them, the construction trades. I know green gardening is another, and I don't know what the other 3 are. Well, I know what they are, but I can't bring them to mind. But they're offering a 7-week program. It's 5 days a week, so it's 30 to 32 hours a week. So it's approximately 7 hours a day for the first 4 days, Monday through Thursday, and then Friday. It's not. I don't think it's a whole 7 hours. Friday, Monday, Tuesday, Wednesday, Thursday, you go to classes all day. Monday, Tuesday, Wednesday, Thursday, Pat and I are teaching the construction aspect of it. It's 9 to 12. And I think there's a break, and then there's an afternoon session. And then on Fridays, they get with job placement and job counseling and do all kinds of stuff. There's an ESL component to it. So English is a second language. That part of our school is involved with it. So we have an ESL female with us in the class. We'll have breakout rooms. So you have to be able to speak English relatively well, but there's help to work on English. You're paid $200 a week. Did I forget to mention that? You're paid $200 a week, and there's $100 worth of childcare also available. You have to sign a contract. You have to be not working. You have to conform to a few things, and not a lot. You have to agree to be there, not miss more than 2 classes. So you basically have to just step up to the plate, and you can get a training, or get at least what some of us have to offer, for 7 weeks. A whole lot of help with job placement and resumes, et cetera, as well as $1,400 and $2,100 if you've got a kid, and I think it's $100 per child. Don't quote me on that, but it's well, I'll show you the flyer. It's a pretty good deal if you're interested, or if you know anyone that's interested. If any of you are out of work and are interested, you certainly would qualify. You can still do this class on Saturday and do it during the week too. So that's happening. That's coming up. And I wanted to take a minute, since I've kind of made this a part of this class. I'm going to just read you three paragraphs from the Four Agreements. And if I have read this before, I apologize. I can read this stuff over and over and over, and I'm looking to see if anybody's shown up. Oh, nice pug or bulldog. Okay, the first agreement is be impeccable with your word. The first agreement is the most important one. It's also the most difficult one to honor. It is so important that with just this first agreement, you'll be able to transcend to the level of existence I call heaven on earth. The first agreement is to be impeccable with your word. It sounds very simple, but it is very, very powerful. Why your word? Your word is the power that you have to create. Your word is the gift that comes directly from God. The Gospel of John in the Bible, speaking of the creation of the universe, says, "In the beginning was the Word, and the Word was with God, and the Word is God." Through the word, you express your creative power. It's through the word that you manifest everything. Regardless of what language you speak, your intent manifests through the word. What you dream, what you feel, and what you really are will all be manifested through the word. The word is not just a sound or a written symbol. The word is a force. It is the power you have to express and communicate, to think, and thereby to create the events in your life. You can speak. What other animal on the planet can speak? My dog can, but his vocabulary is severely limited. Your word is the most powerful tool you have as a human. It is the tool of magic. I'm going to read that again. The word is the most powerful tool you have as a human. It is the tool of magic. But like a sword with two edges, your word can create the most beautiful dream, or your word can destroy everything around you. One edge is the misuse of the word, which creates a living hell. The other edge is the impeccability of the word, which will only create beauty, love, and heaven on earth. Depending on how it is used, the word can set you free, or it can enslave you even more than you know. All the magic you possess is based on your word. Your word is pure magic, and misuse of your word is black magic. That's pretty powerful, I think, personally. Really is real food for thought for me, because I am a wordsmith in verbally speaking and in writing. It's my job. It's what I do. I talk to people and I write things down, and I do proposals and I do contracts, and I use words just like all of us do. Words are they're a big part of our life, whether they're written or spoken. So being impeccable with your word is really important. I'm going to show you.
Thank you for that, Rodney. Appreciate it.
Yeah, you're absolutely welcome. I'm going to show you guys a couple of things, you guys and gals. A couple of things. Let's see. Let's do a safety meeting first. All right. Did I get anybody new? And then just to give you a sense of what's happening, I'll tell you a little bit about what we're going to do this morning. I'm going to show you some plans. Yeah, that I drew, and tell you a little bit about them after our safety meeting. We're going to read chapter 32 in the book. We're going to read it online together. It's not a very long chapter. It's the last chapter in the book. It's on HVAC, which is heating, venting, and air conditioning. I find it super interesting. And I'm going to show you a couple of small videos, short videos, the stuff that if you've gone on the Canvas shell the stuff that you see on there, you may not see the John Hole House. We may not see the John Hole House one. I may be saving that for next week, and it's really a good one. I think you'll really like it. In the meantime, where was I? We're going to try to, after we do the book and I show Ezra, who's a HVAC guy who's doing the job that we've been to a bunch on video, Mangone. We're going to try breakout rooms for the first time, where I'm going to ask you to do a little work together. I think we'll maybe do 3 breakout rooms, depending upon if I get anybody else. So did anybody come in the last 5 minutes? Doesn't look like it. Okay. Okay, let's go to screen sharing. Where am I going with this? Okay, I'll start and then I'll call on some people to read. Welding torch safety. Introduction. Gas torch welding was invented in the early 1900s, and it has been used for a variety and has since been used for a variety of tasks. Just like every tool, however, the improper use of equipment can cause serious harm, but you can protect your safety and your facilities by knowing the procedures, following instructions, using new safety features, and staying aware of conditions around you. PPE, please. How about Jesus Barreto?
Personal protective equipment. Welding gloves. Keep gloves free from greases and oil. Violent reactions can occur when pure oxygen comes in contact with grease or oil. Long sleeves and pants provide proper protection from heat and sparks. Goggles protect your eyes from sparks, debris, and light.
Yeah, that's a good one. Okay, so procedure. Is Donna, have you shown up? How about Mondo? Armando?
Procedure.
Yeah, please.
Inspect your torch attachments, and hoses for irregularities. Check the location of your hoses. Be sure sparks or slag won't fall on them. Purge your hoses by letting them run for about 2 to 3 seconds before lighting the torch. Only use approved lighters. Never use matches, cigarettes, or cigarette lighters to light a torch. Turn on light the fuel gas first. Never light both the fuel gas and the oxygen at the same time. If the flame smokes, increase the gas until the smoke disappears. Add the oxygen until there is a well-defined cone of flame.
Okay, I'm gonna revisit that when we get through. So how about Brenda, would you please read burn back?
Burn back. When the oxygen in the cylinder gets low or empty, the gases start to reverse their flow. The fuel gas at a higher pressure travels up the oxygen line and mixes with the gas inside the hose, cylinder, and regulator. If the lines aren't properly purged before lighting, an explosion in the hose, regulator, or cylinder might occur.
Jose, backfire?
Backfires when a flame momentarily goes back into the torch and then reappears or goes out. You will hear a popping noise when this happens. It is usually caused by overheated torch, or by bumping the tip into whatever is being welded. Sometimes the fire continues to burn and it will be accompanied by a whistling noise. This can be prevented if you don't keep your torch too close to what is being welded.
Okay, how about Josh for flashback?
When the tip of the torch is clogged, flashback can occur. Flashback is the return of the flame into the torch, the mixing chamber, the hose, or even the cylinder, which can cause an explosion. To prevent a flashback explosion, make sure your tip is clear of clogs. I just lost myself. Oh, use a flash arrestor on your torch. This piece of equipment stops the fire before it can get back into the hose. If you don't have a flash arrestor, destroy the fire by turning off the oxygen.
And I'll read the conclusion. Take your time to be sure you're using the welding torch correctly. Remember to wear the proper gear, inspect your equipment for irregularities, and take steps to prevent the different hazards from occurring. Now, does anybody have any comments about welding torches, experience, comments, anecdotes, something that happened to you, something you want us to know about that you know? Anybody at all?
Be very careful when you use those torches. I used to use them all day long for years because I used to build trailers. And the first thing, I had really super long hair. I still got long hair, but now I keep it in the middle of my back. But you know what I mean? That slag, it just, when you learn how to use these torches and stuff, they teach you to look for extra, when you're doing this, when you're doing the cutting and stuff, the smoke rises, but if something catches on fire around you, it gives you like a.
Oh, wait a second. I hear a lot of noise in the background. Does somebody have their audio on and they're crinkling paper or something? Thank you.
And so anyways, they tell you to look for extra smoke because it's a wavy type of smoke, you know what I mean? And sure enough, man, my hair was on fire and I had it tucked in and everything,
Wow.
That flag, something else, it gets into the smallest spots. Doesn't matter how, buttoned up you are, it's crazy.
Yeah, well, it's a gas, and then once it ignites, you can be in really big trouble. But did you know, any and all of you, did you know that hair does not burn? Hair melts. Hair does not ignite. It might appear that it's burning, but what hair does is it melts, which is, as far as I'm concerned, even worse. So, welding torches, when you're welding, you got to be aware of all kinds of things. It's not that hard to be safe. Personal protective equipment is really important. Gauntleted gloves, leather aprons, definitely goggles, long sleeves and stuff like that. But just make sure that you've got a good flame. Always light the fuel first, and then bring in the oxygen. And what I found was pretty interesting was this guy here was the needle valves. Because last week we talked about gate valves and we talked about ball valves. These are needle valves. So there's like a pin that goes into a tapered aperture, and that the pin would be the needle. And as it goes into the aperture, it can completely fill it up, turn it off, or back it out and let a little bit of gas through, which is acetylene, a flammable gas, which is we use acetylene in most welding operations, and then oxygen, which we need to have any kind of a fire. And the more oxygen, the hotter the fire. That's how welding works. So I'm going to get out of this screen. Unless anybody has any other comments or questions about welding. I hope you never get burned by a welding torch. It's horrible. So we're not going to really talk too much about welding, just welding safety. Be safe. This thing is up for you guys.
Rodney, a good rule of thumb is to always clean the nose cone before using those, because you never know what the last person was doing with it.
Yeah, so the tip, right?
Yeah, always clean the nose cone of it, because it's, like I said, you never know what the last person was doing with it.
Yeah, clean the tips or replace the tips. Okay, so let's go to, where am I? Let me ask you, did you come in? Emmanuel, Catherine, LeMay, Colby, D'Angelo? Okay. All right, next. Let's, oh, okay. Before I forget, let me go back. This is that thing. There was something better than this though. Okay, is this it? All right, here we go. 7 people signed up. No, this is not what I was hoping to find. Okay, here it is. Here's the flyer. Can you all see that where it says learning unemployed?
Yeah.
Okay. Back to work program, unemployed, 8 weeks. It's actually 7. This must have been an earlier version of this. So the things that we're teaching, okay, I guess it's not 5 things. Well, it says 5 career tracks. That's where I got 5. But this says personal care attendant, green gardener, and construction tech. Oh, I see. Contract tracer and office administration support. So I'm not super sure what a contract tracer is, except that I think it has to do with COVID. And office administration support, I think that's self-explanatory. Anyway, if you are all interested, I might go ahead. See, there's that 32 hours a week free, $200 grant per week, job placement, get a loaner Chromebook and a hotspot. There's ESL along with it. So it's really a pretty cool program.
Is that strictly, excuse me, Rodney, is that strictly in Santa Barbara?
Strictly. Yes,
Okay.
now it's online. It's gonna be all online, I think. Yeah. So I'm teaching summer too. That won't be on that'll be, I think that'll be face to face. This is gonna be all online. So it would not be limited to just Santa Barbara geographically. If that's Brenda that asked me that, you guys could probably get in on that. Basically, I think what I'm gonna do is there's one of these emails I'll just forward to everybody. So everybody will have it, and then you can, if you're interested, great. If you know somebody who's interested, great. We'll get this to you. Okay, so, and actually maybe I'll do that right now. Yeah, maybe I'll do that right now. It's really easy. You guys can watch how easy this is after I figure out how to do it. Where's forward? Where's forward? You know what? I'm not gonna show how ignorant I am because I can't even figure out how to forward this.
You may have to move the screen over a little bit, Rodney. Excuse me, it's Linda. At the bottom, so you can see the other side of the email. Yeah, right there. Then you should be able to see forward.
Is it down at the bottom, you think?
I just saw it, but you scrolled too
Okay,
fast.
there
for me to
Yeah.
see it. There you go.
Okay, I got it. I got it. So this is how we forwarded to the class. 59,161, 59,161. Boom, that's us. Okay. So everybody got it. Now let's go back to. Huh, okay. Okay, so what I did, I don't know if I can show you this. Well, I'll tell you what, I'll show you when I get out of screen sharing, I'll show you my sketching and dimensioning. But basically, I think this is the bathroom. I did a kitchen for them too, but I just finished the bathroom. It's a small room, it's 79 by 82.5. And I sketched and dimensioned and made notes. And then I took my sketches and dimensions, and I gotta figure out how to get this smaller. Anyway, I first did it in plan view. I laid out the room. I figured out the scale, the biggest scale I could fit on the paper, on the page. And I like to use 8.5 by 11 for small jobs, a room at a time like this, because it's easy for me to work with, and it's I can scan it and send it via email. Whereas larger style plans are a little harder to send for me. I have to go to a reprographics place. So shows the room, shows the new WC, shows where the window and the door locations are, the casing. It includes the dimensions that I think are germane to the project: size of the vanity, size of what's left for the toilet, depths and widths of the new cabinets, and where the doors and windows are. And then, so as you see, that's a plan view. The elevations I've lettered is A looking this way and B looking that way. So let's go to A first. So there's the A looking at that wall for storage. We've got the dimension of the ceiling height, that's where the existing chair rail is, which you'll see in another shot. There's existing beadboard on the wall, beadboard paneling up to a chair rail. It's a 60-inch high wainscoting, and I'll explain that in this next screen. But those are the new cabinets I'm proposing. There's an alternate for that wall, for rather than base cabinets at 18 inches deep and upper cabinets at 12 inches deep, full depth 18-inch deep cabinets, full height, full depth. That would maximize the storage as an alternate. This gives them counter space and drawers, which is what they've chosen. And then B wall, which is kind of the coolest looking wall. And what I didn't do, I didn't show the toilet. Something else I didn't show, I forget what. But anyway, existing beadboard, wainscoting, run vertically to T&G beadboard. And then there's a chair rail that caps it. It's 2.5 inches, shows the height off the floor, and then the dimensions of the vanity and what I want the vanity to look like. And I think actually this is what I'm going to change. I'm going to change down here from a standard toe kick. I'm going to make a flush toe kick, and then I'm going to do a kind of a jazzy arched cutout. So it'll look like it's sitting on legs with a cutout for your toes, for toe space. It'll make it look a little more old fashioned. It's in a Victorian that's well over 100 years old. It's called Spencer House. It's 2 stories. That's Spencer, Spencer House. It's at the corner of Victoria and De La Vina. And then this guy, after doing the drawings, from the drawings, from the drawings, I did a scope. Now, this is typically how I like to design room by room. Do a drawing, and instead of keynotes on the drawing, so numbers that relate to things on the drawings as keynotes, I like to do a drawing, get as much information as I can on the drawing, including plan view for starters, then elevations, and then a scope of work. So here's the 22 items I want bid to include in a bid. And so I'm not planning on doing the job. I'm only planning on designing it, which I've already done, and being the project manager. So I will vet the bids. I'll get people to bid it. I've already had, I've given this to one contractor, and to be perfectly honest, I'm trying to get UT Construction, my old company, to do all the work here and not have it go out, to a bunch of bidders. So far so good, because they trust me and they trust my company, because I trained everybody there. And so these are the things 1 through 22 that I want to be included in a bid for the new scope of work, which is demolish everything there and get rid of it, leave the beadboard and wainscot paneling and ceiling paneling, which is also beadboard, remove the crown moldings, patch the drywall and plaster where it's required, new electrical. I put TBD, which means to be determined, because I'm not sure what the electrical requirements are going to be once we get into it, or get a little further along. It'll get clearer. That needs new duplex outlets. If they need GFCIs, which is ground fault interrupters or arc fault interrupters, new lighting, things like that. That we haven't determined yet, that we'll get determined hopefully before start. Then we want the new vanity that I showed. We're going to replumb the waste and the water supply to the sink. Want a new WC, new cabinets by me. And then I describe the style as a hybrid of full inset flush and overlay flush. And some of you, probably most of you, won't know what that means. And at some point, I'll probably tell you, but probably not today. I've called out the style of the cabinets is shaker style with no inside edge detail with it's a recessed panel, which is what I've shown in my drawing. The owner will provide the pulls, paint, new two-piece crown molding, which I'll do a detail of, but I've spelled it out that, I want a 4 3/4 inch sprung cove with a piece below it revealing 1/2 inch. New Carrera marble slab countertops. I've called out the edge and it gets a 6-inch side and backsplash. New sink, to be determined whether it's porcelain or stainless. I suspect it'll be porcelain. An undermount. I put in cabinet pulls twice. I don't know why. Painting the beadboard, and then I mentioned here that there's an existing fan, supply air register, and a surface mounted light fixtures. They can stay or be replaced. They all work, or they may want to replace them. Typically what happens in a complete gut and remodel of a room, if not a house, but a room, is that if it's a complete gut and remodel, it's hard to leave anything old unless it's really goes with what you're doing. And people usually like to replace them, and there's good reasons for that. It's nice to have all new stuff. So I call out a new tile floor and a new painted baseboard. And then I'd like the contractor to clean up, protect the site, provide a portable job site restroom, and then coordinate with me all phases of construction. And that, folks, is that. Okay, now.
Those were very nice drawings there.
Hey, thank you. And I will continue commenting a little bit about those drawings. Is that I am super old school. I don't draw on CAD. I'm semi-computer literate, and I understand CAD drawing. And if you don't know what I mean by CAD, capital CAD, that's computer aided drafting, which is pretty much where drafting is these days with virtually everybody. Certainly everybody that does it commercially, most everybody I know. I like to draw by hand. When I say old school, I like to use the stuff I've showed you. I like to use an architectural scale rule, 1/4 inch graph pad, 7mm pencil, an eraser, an erasing shield, and drawing templates. And I like to draw by hand because it allows me to design. My ideas come right into my drafting implements, and it gets real on paper to scale. And I work out all kinds of building problems and where things go and how things go. And I'm sure I could learn how to do it by CAD, but I like doing it old style. I really like it a lot because a lot of times, I'm not as sophisticated as a lot of people. I may want to draw right on site, something I just I want to get something like this. Like we were traveling. I don't know if you can see this or not. It's pretty small. We were traveling, if you can see that tile, a couple of summers ago, and there was some question about the weight of these giant doors at the piano house. And I had to draw that to scale so I could take it off so I could get the exact sizes of the stainless steel tubing and then get weights for the tubing per I guess per square inch. Anyway, I had to figure out what they weighed, but I had to draw it first. And it's really nice to have the tools, my drafting tools fit in my clipboard, and I really like it. So what we're going to do, gang, is this is going to be HVAC day. Not all HVAC day, but we're going to go to the last chapter in the book. You can open your books if you like, or you can follow along on the screen. It's your choice. Doesn't really matter to me, one way or the other. So let's go to the online textbook. And here we go. And what we're going to do is we're going to just read through this. And we're going to read through it. I'm going to call on people to read. And then we can, if you have questions, when the next person gets called on, unmute yourself and chime in, excuse me, and ask a question. So I'll read all the way to the first heating and cooling principles. So
Rodney, excuse me, it's Linda again. On Wednesday, Jim had pushed some kind of button and it really optimized the volume. Do you have you done that yet today? And do you know what I'm talking about?
No, I have no earthly idea what you're talking about. So is that better? Are you having trouble hearing me?
Yeah, I'm really straining to hear because I'm mishearing things. You're saying something and I start writing one thing and then I realize I misheard you. So then I have to go back and rewrite it. And I remember, like I said, Wednesday, I don't even know what Jim did, but he said, oh, let me optimize the sound. And he did something and then it was like crystal clear.
Well, I'll call him at the break and try to find out, Linda.
Okay, all right. Thank you. Thank you.
bet.
Sorry for the interruption.
That's all right. So learning objectives. After studying this chapter, you're going to be able to explain how heat travels through buildings, identify ways to conserve energy in housing. You're going to define AFUE and SEER ratings, list the appliances to which they're applied. You're going to be able to list the characteristics of different central air conditioning systems, describe the functions of HVAC system components, explain the design and operation of HVAC systems, describe the automatic controls for heating and cooling systems. The technical terms that we'll be going through here will be annual fuel utilization and efficiency, that's the AFU, air exchanger, boiler, central heating, condenser, conduction, energy recovery, convection, cut-in point, cut-out point, differential, direct heating system, duct, electric radiant heating, electrical resistance, baseboard heating, energy recovery, ventilator, evaporator, forced air perimeter system, heat exchanger, heat recovery ventilator, heating season, performance factor, hydronic perimeter heating system, hydronic radiant heating system, manifold, oh God, one pipe system, plenum, radiation, register, the second law of thermodynamics, which I love, seasonal energy efficient ratio, that's SEER, thermostat, two pipe system, and zone. So I'm going to keep reading. I'll read this whole first page and then I'm going to call on somebody because actually I want to read the second law of thermodynamics. I want to read that out loud. I know what it is, but I want to get to it and read it to you. So it's just a couple paragraphs away. The installation of heating and ventilation and air conditioning, HVAC, is an important building trade. Without it, buildings would not be comfortable places for working or living. They would be either too cold or too hot. Even prehistoric humans with limited technology at hand used open fires to heat their dwellings. Duh. Industry has heavily invested in developing heating and cooling systems. Technology allows for automatic control systems so that buildings are kept comfortable year-round, regardless of how hot or cold the weather might be. So, heating and cooling principles. This is my favorite part. When I learned the second law of thermodynamics. To understand how furnaces and air conditioners operate requires an understanding of how heat moves. This brings up what is called the second law of thermodynamics. And if somebody could tell me the first law, that would be great. Second law of thermodynamics reads, this law dictates that heat always moves from hot to cold. heat always moves from hot to cold. Consider what happens when you place a metal spoon in a bowl of hot soup. If the spoon is left there for any amount of time, it becomes hotter as the soup becomes colder. Why? Heat in the liquid move to the cooler spoon. Okay, so I'm just gonna go down the list here. Dario, did you show up? Jesus, you're here, right?
I'm here.
And actually, I'm sorry, Jesus, I'm going to save you for last because you read earlier. I'm going to go from the bottom of the list up. Dennis Vega, would you please read for us how heat travels?
Heating and cooling of buildings depends on the fact that heated matter, whether air, liquid, or solid, passes its heat on the cooler matter. It does so by three methods: radiation, conduction, convection. Radiation moves heat by way of waves similar to light or radio waves. A source such as the sun produces the heat and sends it through the air. The air is not heated, but solid objects that the waves strike absorb the heat.
Okay, stop for just a second. So in radiation, you're in front of a fireplace, you can get the radiant heat. If you're behind the person that's getting the radiant heat from the fireplace, you're not getting any heat. If you put up a piece of cardboard in front of yourself, in front of that fireplace, you will not get the radiation from the heat. It blocks the rays. Go ahead, Dennis.
Conduction is the movement of heat through substance from one end to the other. Heat moving through the metal spoon placed in a bowl of hot soup is a good example of conduction. Convection is the movement of heat by way of a carrier, such as air or water. This carrier may move naturally or, in the case of fume or furnaces and air conditioners, by the action of fans or blowers.
Thank you very much. Aurelio, could you take us into conservation measures, please?
Yeah, can you zoom it in a little bit? I'm having a hard time.
What is it you want now?
Zoom it in for us, please.
If I can. Really, you guys are not seeing my screen? Okay.
No, I struggled.
Yeah, it's small.
It looks like there's a full screen option to the left-hand side, the one with the arrow. The third down, fourth down. Oh no.
You mean that one? That's research.
I can read that now if you scroll down.
Hang on. Yeah, I don't see a full screen option on this, but you can read it now?
Yeah, and that's much better. All right. So fuel costs are constantly rising. Before discussing space conditioning, heating or cooling mechanisms, it is necessary to consider how to increase their efficiency through conservation measures. New homes are designed to limit the amount of energy needed to heat and cool them. Saving heating and cooling come about in several ways. Chapter 17. Thermal and sound insulation discussed many of these measures. Furnaces and air conditioners are major users of energy in a home. Assume that the efficiency of a low-efficient furnace is 80% for every 100 British thermal units, BTU, of fuel energy consumed. The furnace delivers 80 BTU of heat energy. The other 20 BTU of heat energy from the fuel is lost. Much of this lost energy escapes up to the chimney. Temperatures in a chimney must usually be around 300 degrees Fahrenheit, 150 degrees Celsius, for the chimney to draw full combustion gases to the atmosphere. High efficiency furnaces make use of technology to deliver more heat energy from fuel. Some systems are rated as high as 96% efficient by the U.S. Department of Energy.
So there's a picture of a typical forced air unit, the primary heat exchanger, secondary heat exchanger, the blowers. This is a very typical furnace. And I just want to stop for just a second here. Can everyone hear me? Linda, can you hear me too?
Yes, I can. Thank you.
Okay, and then like I said, as soon as it 10 something, I'll call Jim on the break and see if I can't find that button. And then I'll tell you my button anecdote. So I just want to visit this 90% efficiency. So most of the heaters, forced air units that you're gonna be familiar with that were installed, up till 10 years ago, and even now, because they're cheaper to buy, not so much install, they're cheaper to buy, is an 80% efficiency unit. They have to be minimum 80% efficiency, so they might be 81, 82, 84. And what that means is that 80% efficiency unit means that 20% of the energy of the heat is going up the flue, and it's exhausting at 300 degrees Fahrenheit. That's really hot. So you've got to have a special flue, and as it passes through the building, as it passes through combustible structures like the roof and the ceiling. If it's going through the ceiling or roof, it's got to have a triple wall insulated collar. It's got to have separation all around anything flammable. And you have to jump through a bunch of hoops to exhaust 80% efficiency furnaces. When you spend a little bit more money and get into a 90% plus efficiency unit, more like 10%. We have a 96% efficiency unit in this that I'm going to show you on this video. That means that all but 4% of the energy created in the heat is going back into the building. So at 4%, that's coming out at less than 100 degrees. That's just over body temperature. So it's not even hot enough to burn something. So you can exhaust those heated gases, that heat, with a PVC pipe, a plastic pipe, and you can exhaust it out the side of the building. It doesn't have to go straight up like you have to do with the 80% furnace. So it's a pretty efficient system. I recommend going with it. We've gone with it and we're really happy with it. So coming up, I got Aurelia. Aurelia, would you please tell us what a heat exchanger is, and can you see that okay?
Yeah, I can see that okay. A heat exchange is a section of the furnace where the heat from the combustion goes and transferred by conduction by...
Whoa, it's scrolling down.
No, I want to show you the heat exchanger. Secondary heat exchanger.
I can't.
Right, primary heat exchanger. Okay, go ahead. Sorry.
Right.
The heat exchangers in the high efficiency units
are designed to extract more of the heat of combustion spent gases, leaving a high efficiency furnace at around 100 degrees Fahrenheit and 40 degrees Celsius. The furnace does not use a traditional chimney. Instead, the gases are exhausted to the outside through a small plastic pipe. Also, there is no contact between the inside conditioned air and the outside air used for combustion.
That's pretty important. Stop for just a second. You have to have makeup air or outside air. These closed systems, we'll talk about that a little later. These closed systems draw return air in the closed system to heat and deliver warm air to the house that it's heating from one area, but the combustion air, or makeup air, to the air needed to create fire has to be drawn from the exterior, not from in the house. Go ahead.
The organization SAHRAE, originally named the American Society of Heating, Refrigeration, and Air Conditioning Engineers, develops standards to rate the energy efficiency of heating and cooling appliances. Manufacturers label their heating and cooling appliances with these energy efficient ratings. The standard used for rating
the efficiency of furnaces.
It keeps moving, Rodney.
What do you mean? I just flipped the page.
Yeah, I lost mine.
I think he wasn't finished though.
Yeah,
I was, but I'm just trying to see where I'm at.
You're at the beginning of the next page.
Oh, there it is. The efficiency of furnaces and boilers is the annual fuel utilization efficiency, AFUE rating. It is a measure of the amount of heat actually delivered.
Okay, I'm going to stop you because nobody cares about SEER or AFAU. Nobody cares about it, really, believe me. Even when you get to caring about it, you'll be talking to somebody besides me. So let's just jump right to heating systems. Let's get into the meat of this thing, right? So if you want to know more about SEER and AFUE, energy guides, etc., read those few paragraphs. But let's go right to heating systems. So keep going, Aurelio, and read us this 32.3 on heating systems, please.
All right. Heating systems. Most buildings have central heating space heating. Heating is the use of heating devices such as fireplaces, stoves, or portable heaters in individual rooms. In central heating, a single large heating plant produces the heat. The heat is then circulated through the structure by perimeter heating or radiant heating. There are several types of circulating systems used with central heating. Forced air perimeter heating, hydronic perimeter
heating,
hydronic radiant heating.
Okay, next is Jose Silva. Jose, you there?
Forced air.
Okay, thanks.
Yeah. In a forced air perimeter system, air is circulated through the large ducts that direct warm air to every room in the building. Figure 32-3, the burner delivers high temperature combustion gases to the furnace heat exchanger. Heated air from the exchanger collects in a large sheet metal chamber called a plenum. A blower forces the heated air and the plenum through ducts into the spaces being heated. At the same time, the blower draws cold air back to the furnace through a series of ducts called the air return. An air filter located in the cold air return filters out dust particles picked up from the heated spaces. Figure 32-1 shows a cutaway view of a high efficiency gas furnace.
Let's look at that for just a second. I think that's this page back. Yeah, that's 32.1, right? Yeah. So there's a high efficiency furnace. Just so you look at, you can look at this in your book too. Okay, and then why don't you go ahead and read that last paragraph, which continues to the next page. Starts with furnaces.
All right. Furnaces may be oil-fired, gas-fired, or electric. Oil-fired units require a storage tank for the fuel. The tank is usually located either underground, outside of the building, or in the basement, near the heating unit. For basement tanks, a filler pipe is usually installed that extends through the wall to the outside for easy access during fuel delivery. Gas-fired units may get their fuel supplied directly from a gas main supply by a gas utility or from a storage tank located on the property. Electric furnaces use the resistance of conductors to produce heat, much like an electric stove or oven.
Okay, stop for a second. It's 10 straight up. We've been at it with each other for 1 hour, so we're going to take a break. So we're going to break until we're going to take a 15-minute break. I'm going to take a big, huge break, quarter of an hour. Be back at 10:15, please. And I'll see you all back then. And then somebody remind me, I'm going to shut off recording, and then somebody remind me where we are, which is registers. I'll mark it too, but we're at registers. Okay, see you guys at 10:15, you guys and gals at 10:15. Okay, okay. Oh, come on. You are falling down on the job. I actually had to think of that myself. It's not
Rodney, don't forget to record. Just kidding. I'm just kidding.
You had to jump on the bandwagon, didn't you? Two things. One thing, Linda, there is no magic button. It's in YouTube. There's an optimize audio in YouTube only.
Okay, thank you.
So, and I'll be sure I find that button in YouTube.
Thank
And then per Linda, who's captioning for Ugo, please, when I have you reading, try to read slowly and clearly, and try to just be careful with your enunciation. Just try to read as slow and as clearly as you can, please. Thank you very much. Come on, Dennis, come back. Eric, Dennis, Jose, Ugo. All right. So I'm going to pin myself. I haven't figured out how to work this board yet. And get so everybody can see it. I would like to illustrate some stuff on the board, but I'm not going to. Before we get back into reading and get into this chapter, I'm going to tell you about forced air. That we're going to go through systems, heating systems in here, and they're all germane. Well, most of them are germane for us. What I mean when I say germane is they are applicable to where we live. We're going to find these heating systems. You're not going to find coal-fired heating systems, though. You won't find oil-fired heating systems. And generally, you will not find any gravity-type systems installed as a central heat in new houses. You'll find direct vent systems, which we'll talk about, hydronic systems, which are relatively rare, although electric hydronic, I've used those myself. But for central heating and air conditioning, let's just talk about heating. Forced air system is the way to go. It's a closed system. It's super efficient if it's set up the way it's designed. And in a nutshell, the way it's designed is your furnace is somewhere in the house, basement, attic, center of the house, in a closet. Your supply air ducts are in the floor, ideally. Obviously, it's a different situation in a slab on grade, but we used to do them floor register slab on grade, and the book tells us how we used to do that, and I'll comment on that when we get to it. But in the meantime, suffice to say that the ideal way a forced air system works is that your system creates heated air, and it's blown by method of electric driven fan into ducting, which supplies hot air on the outside walls of the building, preferably under windows or under inactive doors, like a pair of French doors, the inactive one, the one that stays shut most of the time. The heated air is drawn from the outside of the building across the building to the center of the building or close to the center of the house by the return air duct, which is a larger duct. It's sized based on the size of the rooms, the size of the system, but you have a return air duct that draws air. So it's a closed system. So the furnace heats air, goes out the outside registers, it's drawn into the center of the house, gets reheated, goes back out. And then the unburned gases are exhausted out through the flue. So that's how forced air works. And it's a super efficient system, closed system. It's what most everybody uses, although there are greener systems, but it's a very efficient system too. So let's go back. I'm going to remove my pin. I'm going to go to gallery view. I'm going to share the screen. Let's go back to the textbook. So remember, please, if I've asked you to read, please read it slowly and enunciate clearly. And I think we left off with registers, right?
Yeah.
Okay. So Jose Silva Nunez, would you please, do I need to blow this up for you guys seeing this okay? Oh, correct. All right, so there's before I turn it over to Jose to look. So this is what I just described to you, right? Hot air around the perimeter, cold air too, it looks like. Okay. Okay. Go for it, Jose. Jose Silva.
All right. Registers used with forced air furnaces consist of a grill installed over duct openings in the rooms. They usually have shutoffs for controlling airflow. Some have adjustable vanes that control the direction of the airflow as it exits the duct. As air is heated, it becomes less dense. That means a cubic foot of warm air is not as heavy as a cubic foot of cooler air. This causes warm air to rise and cooler air to settle toward the floor. Since warm air rises, heating registers are more efficient if located at floor level.
Yes,
Since cold
indeed.
air sinks, cold air sinks, cold air returns should also be located at floor level. Registers should be placed so that air is not discharged directly on room occupants.
I'll read the safety note. A flame that is mostly yellow in natural gas-fired furnaces is often a sign that the fuel is not completely burning, which means high levels of carbon monoxide are being released. Oil furnaces with similar problems can give off an oily odor. Carbon monoxide is a deadly gas created by incomplete combustion. It has no odor. An HVAC specialist should test the furnace for safe operation every year. Also install carbon monoxide detectors near the furnace and each bedroom. Most states have passed laws requiring carbon monoxide detectors in home, and our state is one of those. Now, I'm going to just tell you a little something about the old furnaces were gravity furnaces. Like I had one in my house. My house was built in 1930. Down in the basement was a gravity furnace, big old furnace. Big old heat exchangers. It was gas fired, and then gravity and what heat does, hot air rises, takes it up from my basement into my ducts and then heats the house. Not no blowers involved, just gravity and hot air, heated air. Now, the problem with gravity furnaces is that as they age, they besides not burning as effectively or as efficiently because their jets get clogged, all kinds of things happen, is the heat exchangers can crack with age. And when the heat exchangers crack, they let carbon monoxide go right into your duct system. And the problem with it, the biggest problem with it is that you go to bed at night, you turn your thermostat on so your house stays warm on a cold night, and you don't wake up the next day, and neither do your wife or kids, because you've died in your sleep from carbon monoxide poisoning. So it's a serious thing, which is why I recommend you really have your gravity furnaces checked annually and or replaced. So I'll read us to the next page. Warm air perimeter system. This variation of the forced air system is usually intended for a basement area or for a building with slab-on grade construction. The ductwork is installed before the slab or the basement floor is placed. So now this is insane, and I'm gonna make this, and I'm gonna talk about this, and I'll read this part because I want you to see. Okay, so that guy there shows slab-on grade ducting. Now this might be a basement. No, this is slab on grade. So they have run metal duct, and they actually shouldn't be metal. They can be metal, but they for sure want to be galvanized metal, but that doesn't mean they're not going to corrode just because they're galvanized. The ideal is vitrified tile or concrete pipe or plastic pipe. Metal, I've seen metal really deteriorate, but it's all laid under slab, and then the slab is placed or poured, and the registers, you wind up with floor registers. The problem is if you ever have any problems, it's really hard to get to your ductwork, and it's really hard to add rooms and to tie into ductwork, and it's just a big pain. I don't think we do it anymore. So before it's placed, heated air from the furnace circulates through the duct system embedded in the concrete. The duct system encircles the concrete slab at its outer edges. It's connected to the furnace through a plenum and feeder ducts located beneath the furnace. As in the traditional forced air system, the warm air is discharged into the rooms through registers. Floor or low sidewall registers are placed along the perimeter of the space. Air returns to the furnace through return air intakes at high locations on sidewalls or in the sides of the furnace itself. Ducts may be of sheet metal, vitrified tile, concrete pipe, plastic pipe, or other precast forms. In damp conditions, if damp conditions are likely to exist, avoid metal ducts. Metal ducts will corrode and fail over time in damp conditions. So in a forced air system, which we know we like to have the registers low, in a slab on grade condition, you can have the registers be low wall. You can have your ductwork run high up in the attics, and then you can have custom ducts run down through the plate on the interior walls and exterior walls and down through a stud bay and have a low wall register. And those are usually custom ducts, although the duct work is made that thin to fit in a 3.5-inch wall. But it's the ducting is at least 2 or 3 times as expensive as running the kinds of duct that we run now, which you're going to see in the video that I'm going to show you after a while. So installing and maintaining forced air systems. Let's hear about that from, was it Jose? Jose, did I ask you to read?
Yeah.
Okay.
Installation of a forced air furnace usually follows the installation of the ductwork. An HVAC technician installs the unit. The installer must be able to make mechanical connections and electrical hookups. Figure 32-6, the same person may also install the ductwork. This requires a knowledge of certain metal trades, as well as a thorough grounding in electrical principles and wiring practices.
Okay, let's go to the next page. Okay, there's a guy putting together the thermocouple or something. Okay, so go ahead, Jose. Jose, keep going and read us about hydronic perimeter system, please.
Hydronic perimeter heating system uses water as a medium to move the heat from the heating unit. The heating unit is called a
boiler.
A boiler for the simple reason that it heats water, much like a tea kettle sitting on a burner. The heated water is piped to radiators that transfer heat to the rooms.
Okay, stop for a second. Stop for a second. Let's take a look at this. So there's your baseboard units. You have a boiler that heats water and it pumps it in supply. Actually, it doesn't have to pump. It's boiled water under pressure will head in the direction you tell it to. It heads to these hydronic units, which like radiators, radiate heat. And then as it cools, it makes its way back and gets reheated. That's a fairly inefficient system. This is a much, okay, the next one's going to show a much better system. So go ahead, Jose, get back to many hydronic systems.
Many hydronic systems include a manifold, figure 32-7C. This device balances the delivery of heated water to different zones, areas of the building.
That's the manifold. Right there's the manifold. Okay.
The manifold consists of an inlet pipe fitting.
Wait, where are you?
The next page.
Are you back a page? Okay, sorry, go ahead. Sorry. The manifold consists
of an inlet pipe fitting with several outlets for connecting one pipe with others. Pipes from each outlet are directed to different zones of the building. Each of these zones has its own circulating pump controlled by a thermostat for that zone. Hydronic systems vary somewhat. There are 2 basic types of piping layout. One pipe system In a one-pipe system, a single pipe called a main supplies the heated water to room heating units. The heated water is pumped through the pipe from radiator to radiator. Finally, the water now cooled returns to the boiler, where it is reheated to repeat the cycle. This type is shown in figure 32-7A.
The one we just looked at.
Two,
Go ahead.
two-pipe system. In a two-pipe system, two mains are used. One main, the supply main, simultaneously carries heated water to each room radiator. The other main, known as the return main, carries the cooled water from each radiator to the boiler. See figure 32-8.
Okay. so
Hydronic systems.
Go ahead, sorry.
Go ahead. Hydronic systems have an expansion tank. The expansion tank acts as a reservoir for the heated water's increase in volume. A pressure relief valve is also part of the system. It opens to release excess water pressure that might otherwise damage the system. A pressure reducing valve limits the pressure of the incoming fresh water supply. Air purge valves are used to remove any air that has been introduced into the system. These valves are placed at high points in the piping where air is likely collect. Figure
Right.
32-9.
Right on. And so here's the better system. It's more expensive to plumb, but it's way more efficient because your boiler supplies hot water simultaneously to all the hydronic radiators. And then cold water in a separate piping system, after it's discharged its heat, cold water goes right back to get reheated. So it's the two pipe system, hydronic, is a way better system. Not very many people use this around here. You don't see it in Santa Barbara, hardly ever. But you definitely have to have an expansion tank because water, anything heated does expand. It's under pressure. And you need a pressure relief valve in case the pressure gets so big that it could blow. You want to be able to relieve that pressure through a valve and drain that water out to the outside. Two pipe systems provide more uniform heating. All right, I'm going to skip ahead here. And then hydronic radiant. So we do hydronic radiant systems. And I'm going to go ahead and read this myself. Hydronic radiant heating system. A hydronic radiant heating system is similar to a hydronic perimeter heating system. However, the piping is installed in a structural part of the building. Not sure exactly what they mean. Hydronic radiant heating systems can be installed in several different ways. Can be installed several different ways. Can be installed on grade over a thick underlayment of rigid insulation. Concrete is then poured over the tubing. We don't do it that way. Under subflooring with insulation beneath the heating tubes, wood or other types of flooring can be laid over the piping system after provisions are made to prevent damage. Okay, so this is typically what we do. We don't want to crush the pipes or the tubing. Got to be careful of the fasteners. But in hydronic systems, we do a subfloor, and we anticipate 1.5 inches on top of that subfloor to finish. 1.5 to 2 1/4. Actually, we figured usually 2 1/4, usually 1.5 just for the hydronic system. And it's a series of plastic pipe that's stapled to the floor, running out like this. And it needs to be a certain distance, like 12 inches away from walls, openings, things like that, where you'd be nailing. They're very careful about nailing on the floor. But once these tubes are all laid and stapled to the subfloor, they're all connected up to a boiler with a relief valve and maybe a manifold system so you can zone different rooms to use different heat. Then they're poured with a lightweight self-leveling concrete so that they're actually poured in concrete. And then on that concrete, you can lay a wood floor, carpeted floor, tile floor. You can lay a variety of virtually any finished floor. But below your floor is a system that will heat water and allow that heated water to travel through pipes under your floor, which will radiate heat up through the floor. Now, that's hydronic radiant. An interesting thing and a little known thing that maybe some of you don't know about is electric radiant heating. So in electric radiant heating, which was big back east for a while, decades ago, and here in California as well, but really is a product of the 50s. So it's almost not used at all anymore. I'm pretty sure it's not used at all, but there are places, for instance, Bonnymead is one of them. Bonnymead are some
What did you say? I'm sorry, Rodney. I didn't hear that. Where?
Bonnymead. Do I need to spell it? Bonnymymead. Bonnymead. It's Montecito Shores, Bonnymead. It's over by the Biltmore here in Santa Barbara. It's a bunch of like 5 or 6 buildings that are, I think, 4-story or 6-story with underground parking. They're apartment style buildings near the beach, so they're pretty tony, but they had radiant electric heating. And what that is, I don't know how much they get into it here. I think there's just a brief paragraph devoted to it. But what radiant electric heating is there is wire running through the drywall. And so the ceiling drywall, not the walls, the ceiling is hung with this radiant drywall that has electric wires going through it, and it's hooked up to voltage so that when the current is run through those wires, the resistance creates heat, which radiates, and it radiates down from the ceiling. So in a radiant ceiling, you have thermostats that control the heat based on what heat you want the room to be, but it radiates down. And if you feel the top of like cabinets, tall cabinets and entertainment centers, they'll be hot because they're getting the radiation. When there's nothing below it, that radiation goes all the way down to the carpet and it kind of heats the air and heats the house. They're relatively efficient, very clean, no dust, no fans, but they're super expensive to use. Same thing with hydronic or non-hydronic with electric. Electric radiant systems or baseboard heaters. They're very, very expensive to use. Electricity is a lot more expensive to use to heat with than natural gas. So. Who do I got here? I got John. I got Michael Silva. Where are we here? Direct heating. Do we do hydronic radiant? Yeah, we did hydronic radiant, right? Yeah. So, so Michael, would you read about direct heating systems, please? Michael Silva? Michael, did you play hooky on me? Apparently so. Putting a check mark by your name, Michael, for what it's worth, which is almost nothing, but no, it is worth something. He's going to get a demerit. Hey, John Sesser, would you please read direct heating systems?
Yeah. Okay. Direct heating systems. Direct heating systems are those whose heat source does not use ductwork or a piping system to distribute the heat. This category includes many basic types of heating, such as stoves and fireplaces. It also includes electric resistance baseboard heating and radiant electric heat. Electric resistance baseboard heating is simple. It consists of a heating element wrapped in tubular casing. Metal fins spaced along the length of the casing help radiate the heat to the room air. Electric baseboard radiators come in various lengths, from 1 foot to 12 feet, and are rated from 100 watts per foot to 400 watts per foot, figure 32/11. Like the hydronic systems, the radiators are located around the room's outside walls, especially under windows to counteract drafts. This system has some advantages. Easy to install, affordable to buy and install, easy to zone heat. Some models have thermostatic controls so the rooms can be individually heated, self-contained, Chimneys and pipings or storage of fuel are not needed. Quiet operating. The downside is the operating cost. In some areas, electric rates may make this type of heating simply too expensive to consider. Consequently, this type of system is usually used only as a backup. In some parts of North America, it is used in combination with wood-burning stoves or gas-fired furnaces. Another type of electric heating is known as electric radiant heat. Such systems are designed to directly heat objects rather than using radiators and convection currents to heat a room. Heating elements are placed in floors and ceilings in a manner similar to hydraulic radiant systems. As the resistant elements heat up, the wall radiates to the concrete or wood floor, wall material, or ceiling material. Ceiling or wall radiant electric heating and elements may be encased in plaster. This provides a medium through which the heat can radiate.
Okay, that's the one I was just telling you about, the radiant heat in the ceiling plaster, ceiling drywall in this case. So you're not going to see those. You're going to see mostly forced air. You'll see older homes with gravity heaters. You'll see hydronic baseboard. You'll see hydronic whole house systems in newer, more expensive houses. A lot of what you'll see is gas-fired furnaces that are direct vent. That means they direct vent straight up or to the outside. Small heaters that go into an outside wall can direct vent right straight horizontally out the back of the heater with a triple wall collar and a disperser for the heat. And then like you're probably familiar with heaters that go into a wall, say between a living room and a hallway. So they broadcast heat into the hallway, the bedroom areas, and then into the living room. Those are two wall direct vent heaters. Anyway, I can't remember exactly what they're called, but you'll find those, and those are in cheaper buildings. But central air is the way to go. And what do we got here? Okay, so now we're to the place that is, that I don't have a whole lot of trouble with heating, with envisioning it and figuring it, talking about it, explaining it, because I understand it. I understand heat rising. I understand the second principle of thermodynamics, but I'll tell you what, AC, air cooling systems I'm getting closer to understanding them because I'm trying harder, but they're more like magic. Like, how in God's name do these things create cold air? Well, let's see if we can figure it out. I'll read the first two paragraphs and then I'll ask somebody to read. So cooling systems are basically refrigerators designed to move.
Ronnie, could you please slow down just a little bit? We're all doing a lot with our hands, me and the ASL ladies. Thank you.
Cooling systems are basically refrigerators designed to move heated air from a building to the atmosphere. In many cases, the cooling system uses the same air distribution system, ductwork, as the heating system. A system
Sorry, Rodney, I still need you to slow down. You're just reading real fast. Sorry about that. It's impossible for us to keep up.
A system of tubes called an evaporator is located in the furnace where return air from the rooms can pass over it. When the central unit is operating, cooled liquid refrigerant is pumped through the evaporator. Since it's colder than the room air passing over it, the refrigerant absorbs heat from the air and evaporates. This can be compared to water evaporating as it absorbs heat from a stove and turns to steam. Then a hot refrigerant gas is drawn back to the outside unit. Here it passes through another series of coils and fins called a condenser. The condenser acts like the radiator of a car and allows the heated refrigerant to pass its heat to the atmosphere. In doing so, the refrigerant returns to a liquid state. This is super interesting physics for me, how this works. The liquid refrigerant, which is cold, it's pumped through the evaporator and it's colder than the room. So it absorbs the heat, it pulls it in and it heats it up. And then it's drawn through to the outside unit, passes through another series of coils, it condenses, acts like a radiator, and the heat comes out of the refrigerant and it goes back into the atmosphere, and the refrigerant goes cool again and returns to a liquid state, and it's cool liquid state. It's just unbelievable to me. And so in figures 3212, a central air conditioning unit is combined with a forced air distribution system. A coil is located in the furnace and it receives cold refrigerant. Air is forced through the coils, is cool. Air forced through the coils is cooled and delivered to rooms by way of the duct system. From the condenser, the refrigerant is pumped at a high pressure to the evaporator in the furnace. This completes one cycle of the air conditioner. The cycle is continuous as the building's air is passed over the cooling coil. Figure 3213. Okay. Figure 3213 shows an air conditioning unit located outside a home. This is typically what you see in air conditioning. It contains the compressor and the condenser and related valves, and it's operated by an electric motor. And they look like that, or they look square or rectangular. And then there's those plastic pipes that are inlet and outlets. So combustion air, makeup air, and then exhausted heated air or exhausted gases, non-combusted air goes out these plastic pipes rather than a flue out that all the way out the roof, which you'd have to do with an 80% and up to 90. So ducts can be constructed of various materials, including plastic, metal, rigid plastic, flexible plastic. Most ducts are prefabricated. They should be unobtrusive and then fitted and cut on site. Metal duct sections are joined by the installer on site. Controls. Well, we all know what a thermostat is. When you set the temperature on a thermostat, you send a signal, and it's called the cut-in point. That's when it comes on, and then you set it to cut out, the cut-out point, and that's when it goes off. The difference between these 2 points is called the differential. So you can set your heater to come on at 66 degrees and go off at 68 or 70. That's the differential, 4 degrees. Most thermostats are programmable. They can be set to automatically change temperatures different times of the day or days of the week. For example, the temperatures can be lowered or raised if cooling at night and during the daytime daytime hours when occupants are not home. During the hours when people are present, the temperature is increased or decreased if cooling. The result can be significant savings in fuel costs. So what I try to avoid is heating or cooling my house when no one's in it. I don't like to waste energy or money. Okay, we're getting there. Air exchangers, I'm not going to tell you about those. Heat pumps are pretty darn cool. Actually, we'll go through the heat pump part, and then I'm going to show you Ezra. And then I was hoping to do a breakout room, but we'll see. Breakout rooms, but we'll see. So let's somebody read about a heat pump. Who is next on my list? Josh, are you here?
Yeah, I'm here.
Could you read, please, on 32.8 heat pumps? Hopefully you can see it on your screen.
No, yeah, I have the book. So a heat pump combines heating and cooling in a single unit. The basic system includes the following: a pump or compressor for compressing refrigerant, an evaporator and condenser, a reversing valve to switch the functions of the evaporator and condenser, pipes or tubing connecting the evaporator and condenser to the compressor. Like an air conditioner, a heat pump uses a refrigerant to collect heat from one place and deliver it to another location. In winter, it collects heat from the outside and delivers it to the inside of a building. In summer, it collects heat from inside of the building and delivers it to the atmosphere. The secret of heat pump operation is in the reversing valve. By switching the valve, the two chambers are made to switch functions. Thus, in winter, the inside coil becomes a condenser, giving off heat in the summer. It becomes an evaporator, cooling coil, see figure 32-18. Efficiency of the heat pump drops as the outside temperatures dip below 20 degrees Fahrenheit, -5 degrees Celsius. The building must have an auxiliary heating system, or the outside coil must be buried in the ground. Where winter temperatures are higher, as an alternative, the coil can be located in the well. The water temperature in a well may be consistently around 40 degrees Fahrenheit, 5 degrees Celsius.
Okay, I think that takes us to the end. It talks about HVAC installer, but let's take a look at this guy here. Heat pumps are great. Like I have a mini split unit in my cottage, and it has a condenser and compressor, and it has a high, it's mounted high on the wall unit that puts out cold air, but it's also a heat pump. So it'll also take hot air out of the outside and it'll deliver it to the room as well. So it's really nice to have a single unit do heating and air conditioning, and they're very efficient and they're relatively inexpensive compared to air conditioning and heating because they require no ducting. And we can talk about mini splits at some point, but not today. Today, what we're going to do is we're going to okay, I got a bunch of videos here. We're only going to see a couple, hopefully. We're going to see Ezra with no sound because I mic'd him up and he's got no sound. So I'm gonna fast forward through him mostly. You'll notice there's no closed captioning because there's no sound. So you know, I interviewed him. He's very shy. He's a really good guy. He's an excellent HVAC guy, and different than a lot of people that I know in the trades, he decided with his folks, I can't remember where he said he was living, but he decided at a relatively young age that he wanted to go into the construction trades, and that he sat down with he and his father, and they kicked around ideas about what trade to go into. So he decided on the HVAC trade, the heating, venting, and air conditioning trade. They found a school he applied for and got accepted to that school. He went to Phoenix, Arizona and lived there for 11 months and was trained by a school that trains for people for a career as the HVAC trade. And then he came back to Santa Barbara and got a job and worked for someone for I think 11 years until he was competent as a journeyman, and then he started his own company, got his own contractor's license, and now he has I think 4 employees and more work than he can handle. So this is all talking to Ezra. Come on, catch up. So all talking to Ezra. So sorry, no sound. Talking to Ezra. pretty soon, you'll see the reason why I'm doing this is that we're gonna leave the front in this interview and we're gonna go into the house. Gonna go into the house right about here. Still no sound. I do have a clip of him with sound, so you do get to hear him a little bit. Okay, so we're going in the house. It's been ducted, the units installed, the forced air units installed. There's the tub I had to take out to do a little bit of plumbing repair. Now here's the access to the attic, which is where the forced air is. I think we're getting a light. And then we're getting a light, and we're gonna take you up into, and we'll just peek around with Ezra and me in the attic. Well, there's a light, another light, okay. Walking back with light. Following Ezra's knee pads up the ladder. Up into our 20 by 32 or whatever the 24, 32 other our space that's required to get him into the attic where he can access. Okay, so now we're seeing that pipe is for condensate, and there's a little trap there. That pipe, that condensate, because there's a coil up there, creates condensation and water. That water has got to go to a sanitary waste. It's gravity piped down to one of the bathrooms. It ties into the waste in one of the bathrooms. It'll also have a gas sediment trap. When the gas gets hooked up, that's de rigueur. That's something that they've all got to have. This is the ducting. This is 12-inch duct. It's flexible. It's got wire that runs through it that keeps it from collapsing. It's foil lined on the inside as well as the outside. And it's got a layer of fiberglass insulation that insulates it and helps it from cooling down as it's getting cooling down or heating up as it's transferring hot or cold air to the various supply air registers. And I think we'll see the supply air registers in the next. Here I'm talking about the trap, right, for the condensate trap. Condensate waste goes this way and goes down to one of the bathrooms to tee into the sanitary waste. Talking about ducting, I reckon, and hanging this from the rafters is a really good way to go. It gets it up off the deck. You can get around it easier. It makes it easier to plumb. I really prefer it as a method. Just about anywhere you put a heater in a basement, which we don't do very many basements now. Mine is in the basement. It's tough to get around it. Usually have to back it up to a wall. So let's see. I don't know what I'm talking about here. Talking about this switch, perhaps, or what Ezra's talking about. Okay, let's stop that. Let's go here. Now, I want you to hear Ezra, because this second one is Ezra with sound. Okay, we are back recording, and I want to tell you, first of all, I want to apologize because I had Ezra all mic'd up, but I didn't turn on the mic of the receiver. So
we didn't miss much.
My bad. But now Ezra's mic'd, and you may not have heard his explanation of how he got into it, but I might remember some of it. But Ezra, just tell us a little bit about air conditioning. Were you, I suspect, when you went to trade school in Arizona, that air conditioning was probably really high up there as a part of the trade, because who doesn't have air conditioning in Arizona, right?
Right. I didn't work in the trades when I was there at all.
Just the school.
Just the schooling, yeah.
Did they focus a lot more on AC, or just
everything, yeah.
So what about Santa Barbara? How much? Think about of every 10 forced air units you install, are they all with air conditioning? Does everybody get air conditioning now in Santa Barbara?
A lot more recently, last few years.
last few years, but
Yeah.
generally, if I remember correctly, nobody needed air conditioning here I never wanted air conditioning until about 5 years ago.
Yeah.
Now I want it every year.
Yeah.
So now it's kind of like, yeah, those 5 or 6 or 10 or 12 or 14 days in a row that are over 90,
Yeah.
people remember that.
Just wanna be
and
comfortable.
They want AC for those times, right?
Yeah.
So to make AC work, the components of that, could you tell us about that?
Sure. You've got to have an air handler. So in this case, it's the furnace because it has a blower in it. So the air conditioning and the furnace share the blower. And on the furnace, you attach the AC coil, the evaporator coil. And it's a box that attaches to the furnace. And
So you could have the furnace and just not attach an AC coil. It's the same
Correct.
Furnace, but if you wanted to have air, you got to add the AC coil.
correct.
Okay.
Yes. And from that evaporator coil, you have your refrigerant lines. So you have a suction line and a liquid line. The big one's the suction and the small one's the liquid. And then
Insulated line is what is it again?
it's the suction line.
And what does it do?
This is being drawn back to the compressor at the condenser, the big line. So the big line, insulated line, is going back to your compressor outside, and the liquid line is the one being pumped into the coil. And then there's a metering device inside the evap coil that changes the state of the refrigerant, and just part of the cycle of the refrigeration.
So for me, the forced air is pretty easy to comprehend. You know, that you have gas as a heat source, you ignite it, you heat the air, you blow the air throughout the house through ductwork. Air conditioning is a little harder to understand. Can you just tell us how in the heck does this turn like ambient air into very cold air? How does it work?
Comment spot. It's just so you have your outdoor unit, which is the condenser outside, and that's got the compressor in it, which is the heart of the system,
And that
basically.
sits on a pad and it has to be outside the building.
Yes, should be outside the building. Yeah.
You never put it inside, right?
In some commercial stuff, I've put them up in some attic spaces because there wasn't other options. Yeah.
Okay, but generally, they're outside the building.
They should be, yeah. So they can release the heat being absorbed by the refrigerant and pump it outside, because there's another fan outside that blows the hot air up and out.
So it actually takes the heat out of the air? Is that what it does?
The refrigeration absorbs the heat inside, yes.
Wow. And then it exhausts it out there. And then how do you wind up getting cold air? How does it get cold?
It's just changing the state of the refrigeration. There's a metering device on the indoor unit that just changes the state from, this is where I gotta sit and think about it.
It's
But
like magic.
is that,
This
well,
Freon we're talking about?
yeah, refrigerate, right.
The refrigerant that we use.
Yeah. Just changing the state from, it gets pumped out as a liquid coming through here. That's why they call it the liquid line. And it goes to a metering device, which lowers the pressure, which, I can't explain more than that because I'm not smart enough, but it allows it to absorb heat from the airflow being pumped across the coil.
It's still magic to me. It's as magic as electrical. It's flipping the switch and having the lights go on. Tell me I push the button to record.
I wasn't well prepared for this, Rodney, honestly. I've been dreading it so much.
Yeah, push the button, record. So let's go walk around and look at some of your ducting, especially the special duct that we're looking at, and also just looking at, while we're in here, hopefully you can hear me on Ezra's mic. This is Isonine, or this is open cell foam, and it allows us to insulate with an R value that's consistent with what we need. I think it's R30, and it allows us to have a vaulted and open beam ceiling without having to vent the rafter base. And I'll tell you more about that in class. And this is our unfaced bat insulation throughout. So Ezra, let's go over and just talk about your ductwork for a minute, and then I know you're just loving this one all day. Have I mentioned the whole vaulted ceiling thing and insulating rafter bays? Have I talked to you guys about that? No? Well, just briefly, If we want a vaulted ceiling, that is an open beam type ceiling in a house and not an attic that we can vent properly and insulate, we now have to vent the rafter bays because the ambient temperature on the outside versus the inside temperature can create condensation, which can create water. We can get water into those rafter bays and get wet insulation and drywall screws that rust. And so to obviate that, to get rid of that, if we have a vaulted ceiling, we have to vent the rafter base. So we have to have wider rafters than we need. You know, if we needed a 2x8, we'd go to a 2x12. So we have some space for air to travel. And then we need to vent out the freeze blocks or out the eaves. We need to vent those bays. And in some cases, we can vent one bay to another and vent that one. But we have to jump through some hoops to vent those bays unless we use this closed, well, this in this case, this is open cell, but unless we use a foam type, Icynene type insulation, which we have, then we can just skin those and we don't have to vent the rafter base. Pretty cool. Bye, George. I might be able to just let you go after that. Let's go. We'll go over and check your duct work out. I'll follow you. So, right here. So because you have a furnace in the attic, I mean, it seems to me ideally, for as I remember it, the ideal forced air is floor registers. But if you have slab on grade, that's very, very difficult to do. And it used to be done, and I'm telling you, it's a bear to work on. Those, you know, big ducts underneath the slab.
Yeah.
Just really, really a toughie. So generally, if you have a slab on grade, you're not going to have floor registers. You're going to have high wall registers, and that's what we've got. We've got, what is it, 6x16 or something like that?
Yeah, I think it's 6x14.
6x14 high wall register, which is ideal for air conditioning. High heat rising is not ideal, but it's not bad. Believe me, this house will be warm. And the insulation is going to help a lot. So let's go look at this special duct, because we had a special problem here. And the problem was how to get with this open beam ceiling, because remember, in here, we're going to show all these cycle trusses with the painted, but that's what it's going to look. That's what it's going to look like. And if you live in addition, again, we have a vaulted ceiling, which we did with an open cell Icynene foam. So we wouldn't have to vent the rafter bays out at the eaves, which I'll tell you more about. But I had to figure out how to get, or we had to figure out how to get air and cold over to the garage, which is going to serve as the owner's office. You can use it as an office. It can still be used as a garage, but he plans to use it as an office. So we want to get him duct over there. So Ezra, what did you do? How'd you do it?
Well, there was a void over here in the corner that we could get a duct through. And basically just cut out some of the framing that wasn't structural and ran a duct across that you're going to build some sort of chase around.
We are. So
Stop it.
Ezra is actually not tooting his own horn as much as he should be here, because he really figured this out. And we needed a custom sheet metal part of the ducting just to hold the register, right? That thing right there, insulated as it is, and that'll get boxed. The whole thing will be boxed. It'll be boxed. The box will be underneath here, and it'll go straight up like that and around that guy. So it'll just be a big, it'll kind of look like a beam, a box beam or a chase. And then this will put ducted air or cold air and hot air into this room. We've got 3 supply air ducts up high on this wall, and then there's one ceiling. I think we have one ceiling duct in the garage /
Yes.
office, and that's going to need to get a fire damper because we need a separation for it as a garage. I just want to forget that. Really clean work. So let's just would you come over here for a second? We're going to say goodbye. Okay, sorry about all the moving around. So, Ezra, if you could tell my students something, you could tell them something about being a tin bender and HVAC guy, what would it be? What little piece would you want to give them, just off the top of your head? What pops in your head? Like, don't be ridiculous and do this, or wear chainmail chainmail gloves when you?
Yeah, I mean, it's hard work, but can be satisfying.
Does it pay off? Is it a decent trade to be in?
It's a good trade. You learn a lot from this trade. You learn a little bit of plumbing, electrical, mechanical. So you learn a lot from it, which is good. If I had to do it over, would I do it again? Probably not.
No?
No.
And is it because of the contracting and just?
It's all of it.
problems?
Yeah, there's a lot
Problems
of stress running a business, especially contracting business, which I'm sure you
Yeah, I do.
can attest to.
And especially, and for you, I feel for you because you're in that position where you're, even though you have Krista, you're still running the business end and you're still working.
Yeah.
It's really tough because the business end, as you get bigger, takes so much. And the other thing I want to mention is that, if you have a problem in your house, there's all kinds of problems that don't need immediate attention. And then there are lots of problems that do need immediate attention. Plumbing problems usually need immediate attention, but heating and air problems need pretty much immediate attention. Like when people, as cold as it's been, and they don't have heat, they need you there. And that's gotta be stressful. It's gotta be.
Yeah, just trying to,
Oh, that's what my kids are freezing.
yeah, pile in service work that's not scheduled in with your scheduled work. It's gonna be tough.
How far do you roam? Which territory?
Yesterday I was in Ventura, and I've done a little bit in Santa Maria, so you could say Ventura to Santa
Pretty
Maria.
big, and you're based in Lompoc.
Yes, yeah,
That's
but
a pretty big area to service, but I'll tell you, I can tell you that I had a lot of HVAC guys, and Ezra is beyond belief. Plus, I mean, look at him, he's so cute.
it's just not a good interviewer, that's all.
Yeah, you're great. You're great. Thank you so much.
Yeah.
You just say bye, class.
My class.
He meant to say he's not a good interviewee. I'm sure he meant to say that. So I'm going to show you 2 quick recordings, and then we're going to take a fairly short break.
Can we take a break now, Rodney, please? I mean, we've been going really hard and fast for an hour now. So do you think we could break now? Would
Who's
that
in
be
charge
okay?
here? Wait, who's in charge here? Yeah,
I-
I'm in charge. So yes, Linda, we can take a break now. Come back at, take a 10-minute break, come back at 11:25, please.
Thank you.
You bet. Okay, I'm looking for everybody to come back. We're gonna do something brand new here. Brand spanking new. I'll wait till I can see everybody. Most everybody. Donna, what happened to you? You were here, now you're gone. Huh. Wow. Okay. 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 Jose and Brenda are coming back. Everybody's back online. It looks like I'm going to try breakout rooms for the first time. I'm going to create, I think probably 3 breakout rooms. Yeah, I'm going to create 3 breakout rooms. And I know I got to put Lindsay and Katie and Linda and Ugo in one breakout room. And then I'm going to put a couple other people in it with you. This might even just be 2 breakout rooms, but I'm gonna create them in a second. Once I create them, you'll get a breakout room tab down below that you can access it with. But when you get in there with each other, and I'll come in and see you, we're gonna be in there for maybe quarter till, so maybe 20 minutes or so. I would like you to discuss this chapter, and I want each room to come up with 3 things that they think is the most interesting thing they got out of this chapter. So you guys kick it around, see what you think is interesting, what you find is interesting, and then come up, you can assign somebody to write down the 3 things, but come up with 3 things per group that you found to be really interesting and something you didn't know before. Okay, so let's try this out. Here we go. Josh, I hope you're coming back. Breakout rooms. I'm going to assign manually. And I'm going to create 3 breakout rooms. And in room 1, I'm going to put Ugo, Linda, ASL. I'm going to go ahead and put Armando and Aurelio. Okay, you guys are in breakout room 1. All right. Okay. Now breakout room 2. We're gonna put Brenda and Jesus in the same room. That's pretty kind of me, huh? I didn't want to separate you guys. I couldn't bring it to myself. And then we'll put Dennis in that room and Eric. And then for room 3, I'm gonna have Jesus, John, Jose, and Joshua. So you guys are now, when I click this button, you'll all be in your breakout rooms, and I'll come in and see you, and then I'll end the breakout rooms at maybe a quarter to, okay? And starting now, remember, you guys are going to discuss what we read in that chapter 32 and come up with 3 things between whoever's in the group that you found interesting and something you didn't know before.
it. But also we always have issues with the attic getting too hot because the hot air rises all the time. So we would have to find a way to like maybe a heat pump, you know, to pump it into the walls and then have it go into the rooms, you know, just because the hot air always rises and then the attic would just get super hot.
What was the question? Were you answering a question, Aurelio?
No, we were just kind of going back and forth on what systems and why would they do something, you know, different than what we have now. He was just talking about adding that like, what was it, the hydronic perimeter system maybe in the attic. And then I was telling him maybe we would have a heat pump or something pumping it into the rooms, like maybe through the walls, because you know how heat air goes up, attic's always hot. We have to have the right ventilation in there. So, and he was saying like any leaks can be, you know, they would show faster because it's coming down on the drywall or something.
It's an interesting idea. I've never heard of anybody doing it, but I mean, as we all know, if you've been in an attic in the summer,
it is
they can-
boiling.
Yeah. Yeah.
Even if you have the vents, it's still hot.
Oh, for sure. I have a fan that comes on that's thermostatic controlled, a giant fan in my attic, you know, to exhaust hot air, which really helps. Insulation really helps. But I've worked in Palm Springs, and man, you got to be there before sunrise, and by 9 in the morning, you're out of the attic, or you're like a raisin.
Yeah, it's no fun. I mean, I've been up there because I get the end of the boot, you know, and then, yeah, it sucks.
Yep. I'm gonna go in room 2, but you guys keep the dialogue going. I love it.
All right.
What was the third one?
That's what we're trying to come up with.
Yeah, that's what we're working on.
We already got the first two.
Got any
No
suggestions?
cheating. No cheating. There's no cheating, and no one. You can't cheat this class.
Oh, let's see.
We could go to where Rodney asked a question for, he wanted to know what the first law was.
Yeah,
He said,
that'd be a cool thing, because you could piggyback right off this chapter, because now we all know what the second law of thermodynamics.
We don't know what the first one.
It'd be good to know the first one.
Yeah, the first law of thermodynamics.
You know what? I'm gonna guess that it is.
What?
I'm gonna guess that it's heat rises.
no, it's
Oh, he looked it up, actually. I didn't.
I would expect nothing less.
I've taught him well. Do your research.
Yeah, you listen, women raise kids and husbands.
Exactly. It's my third child right here.
Right, that's right. Yeah, and my wife's leaving for 2 weeks, April 1st. And so
internal energy, Rodney.
Where's she going?
I'll tell you in a second. What is it, Jose?
Internal energy.
That's the first law of thermodynamics?
Yeah, it says the first law of thermodynamics is a vision of the laws of conservation of energy adapted to thermodynamics process. It says distinguishing two kinds of transfers of energy as heat and thermodynamics work in relating, here, let me see, in relating them to a function of a body's state called internal energy.
Okay, well, I understand virtually none of that. So
Right.
I have to read it word by word, but just Brenda, to answer your question,
Yes.
she's going to her folks in Wichita, Kansas. But my big question when my wife goes away is, who's going to feed me?
I was just gonna say, life. What are you gonna eat?
Who's gonna feed me? I
Right?
mean, really, I can wash my clothes, I can clean I can do everything, but who is gonna feed me?
Actually, Jose's a really good cook, so he's been cooking a lot lately, and I'm appreciative of that.
Yeah,
I just have to. I got to teach him to wash clothes, though. He doesn't know that part.
Oh, I won't teach you because I'm an excellent at it, but I'm going to go into breakout room 3 and check it out. You guys keep going, keep the dialogue going. I need good stuff in here, please.
Yeah, the law number 2, Rodney, is heat transfer.
You mean 1?
No, number 2.
Yeah, well,
Well,
that's
2 is that heat always travels to cold.
That's what I'm saying. It's a heat transfer is number 2.
Yeah, we
But
know
the
that
number 1, that's
Okay, so
what it gave me.
let's discuss that one.
Okay.
If
I'm
not,
pretty sure John. I'm pretty sure John knows most of this already. So
he has the basic understanding.
yeah.
Oh, hey, don't talk about Rodney anymore. with Ben.
We'll come back.
Yeah. Well, you know, if you guys were using your heads, you'd be saying really glowing, positive things when my picture popped on. You'd be going, yeah, that Mr. Rod, he is so cool. But have you guys been having a lively dialogue or a dialogue, I hope? And by the way,
Yeah.
before you answer that question, I did piggyback a little bit on what I thought I heard you saying. But yeah, Cesar's a pretty accomplished guy. He's been working for me, with me on this job I'm doing, and I'm really, really enjoying you, John. Really, you're a good guy. You're a good guy to have in the trades, and you got a good attitude and a good work ethic, and you're tooled like crazy. So use Cesar as your classmate, as a resource. If you're interested in this, because he's pretty well, he's got a good broad base of knowledge, and he's well tooled. You know, and those are the kind of questions that we ask if we want to get into the trades. One of the first ones is, what do I need? You know, what kind of tools? What tools do I need, really? And I'll tell you, this might be off topic, but it depends on where you're going. If you're going entry level, you need no tools, really. You know, depends on the trade, but tape measure, maybe a nail bag. Ask your guy, whoever you're applying for a job for, what tools should I have? What tools? Because if you're going entry level, you're not expected to bring a bunch of tools to the job, right? If you're going journeyman level, if you're getting the exorbitant amount of money that John is commanding, then you've got to be tooled. You know what I mean? You've got to be tooled up. You got to bring your knowledge to the party, but you got to bring the tools to do it. And that's how you make more. You know, the more you make, the more knowledge you gain, the more you can do, the better you can do what you're doing in the trade. And of course, you got to get more tools, because it just takes tools to do this, you know. And then I'm at the point, because I'm talking, so I'm going to toot my own horn, where I've used tools all these years, decades, man. Like, picture my hands going to 50 years of using tools, and actually less than that. I think I used tools for closer to 25 or 30 years. But then the tool I started using more and more was this tool. And so this is the tool that I use now most of the time. I still can use my hands, and we will build things when we get back together, but mostly I use this tool. And that's the tool you develop all along until, you know, you can use it more, because I find it more fun, and it breaks down less. Doesn't need any oil, just food. What were you guys talking about?
We went over differences in efficiencies in heaters.
Yeah.
So, you know, the 80% of conventional, 96 plus for high efficiencies, and what
That's pretty damn interesting, isn't it?
Yeah.
I mean, did you guys know that before?
Oh,
it's wild, huh? That you got the choice. I mean, you go call up your HVAC guy. You want to buy a heater? He's going to say, "What do you want? Do you want to spend $5,000 for 80% efficiency, or do you want to spend $8,000 or $7,500 for 90% efficiency?" You know, if you've got the money, you're going to want to go the higher efficiency for a variety of reasons. It's more efficient, uses less energy, to create the heat, the energy that you want. It uses less energy. You pay less. It's better for the environment, and you can duct the dang thing. It's 100 degrees. You know, if you've got a forced air unit that's 80% efficiency, don't touch the flue. If it's 90% plus, you can put your cheek up to the flue. 100 degrees is not going to burn you. It's going to just warm your cheek up. So yeah, keep it up. You guys, I love to see some dialogue. This is, I think that I want to get some feedback on this breakout rooms. This is our first one, but please keep it up.
Hot air is lighter than cold air, so it's always going to rise. So that's just physics and, you know, just the way it works.
Yeah, okay. Yeah, since like hot air rises, I'm pretty sure like they kind of build it out to make it work out that way, make it vent that way in some sort of way.
Yeah, you can manipulate it to do, you know, go up certain areas.
Mm-hmm.
Oh, I gotcha. Okay. Thank you.
It's kind of like we're manipulating the air going into a car, the air intake system, manipulate it to do, you know, the speed we want, how fast we accelerate it. It's kind of the same. I mean, in a sense, it's somewhat in a way that we put our ventilation.
Do you know what the Venturi effect is?
No.
Don't.
So the Venturi effect, Venturi, named after an Italian guy long time ago. I'm going to paraphrase it, but it's the effect that governs anything that's moving, air, water, solids, that when the aperture of the flow, when the aperture of the channel is reduced, the flow is increased, right? So water, a body of water, when you decrease the aperture that it's flowing into, the flow increases. So that's how carburetors work. They work based on the Venturi effect. They take in air at a certain diameter on the intake, and they reduce it, and they reduce the aperture And so the flow increases. And that's a principle that's used in all kinds of stuff, but Venturi effect. But it's the Venturi effect is like the fact that heat rises. It's a physical principle in the universe, and it's not going to go away, and it's not ever going to go backwards. It's something you can count on, just like you can count on a 3, 4, 5 right triangle is always going to be 3, 4, 5 triangle is going to create perpendicular or square. Anyway, so it's concepts like these that I just love to learn, as well as the mechanics of this stuff, because I just feel like it broadens my understanding of the universe. And that's my 2 cents worth. I'm gonna
feel like I have it right.
I'm gonna visit the other 2 rooms. So keep going, and then at some point you'll just magically appear. I'll magically close the room. You won't have anything to do with it, and we'll appear in the class together. But please. Keep going.
And yeah, and the big bear came and pushed it all in. But yeah, it's definitely cold over there where you need that heat.
Yeah. So we get our 3 subjects?
Yeah, I'm trying to figure this one out.
I figured out. Hey, Rodney.
Magically, you'll be transported magically back to the classroom in a few minutes. So keep up the dialogue. This is great. I love to see the smaller groups, you guys talking to each other. It's fantastic.
Off limit. Hey, Rodney, how many people were you short for 115?
I think it was like 12 out of 16. Oh,
Yeah,
2?
two. We could have flown with 2 because I think at one point I could count on 14. And yeah, they wanted 16 minimum for it to fly. So yeah, and that's probably the standard they'll hold me to this summer too.
Man.
So we'll see. I mean, I wasn't really all that excited about teaching in the summer. Personally, I want to take the summer off and pull my RV to the East Coast. But if the class will fly, I'll teach it, man. It's after teaching these classes, the CT 111 and this one we're starting up, I'm really looking forward to CT 115 and 14 because I've been doing those a while. It's a much more familiar territory for me, and so it's easier. I guess it's easier. These have been hard for me because I've had to do a whole lot more work, and by the same token, I've had to learn a bunch, which is actually pretty cool. And when you get as old as I am, you have plenty of opportunities to learn. I think not as much as when you're young, but they don't look as attractive to me. It's kind of like, yeah, fuck no, I don't want to work and learn. I want to just like coast, okay? But I really do want to keep learning because that's how that's how you don't grow old. You stay vital, stay active, and keep taking those challenges. Okay, I'm gonna go back to the main. I'm gonna magically, you guys, hopefully you got your 3 things. I want to spend this time together. So you will magically be reunited with everyone in the class and just shortly.
My screen actually blacked out, so I couldn't really see what was going on. I can't hear you. Hold on. Very weird. No, I can't hear. Dang. Oh, we're all going back on.
Sorry, Armando, you can hear me now, right?
Oh yeah.
Okay. Yeah, sorry. So you got kicked out?
We had tech issues. I had to get my other laptop.
Okay, glad you're back. We won't be here much longer, but I want to get some feedback. Did everybody come back?
Rodney, excuse me. I don't have my dialogue box now. Could you please invite me to be a captioner?
You're on there to caption.
I'm seeing the closed caption thing at the bottom of my screen.
Yeah, you're on there, Linda. You're on there and assigned. So I could
Yeah.
unassign you and then reassign you if you think that'll help.
Yeah, could you try?
You guys see Linda's captions?
I don't see it. I might have missed it. Sometimes it pops up so fast
Yeah,
that
yes,
I
Sorry.
missed.
I'm sorry, Josh, what were you saying?
yes, it says captioner Linda.
But do you guys see, do they see closed captions too, Linda?
I don't know. I don't know how this works.
Do you guys normally see closed captions?
No.
No, just Ugo is that's just for Ugo's.
I think that's just the way it's supposed to be, just,
Okay, so
Ugo,
I'll tell you what,
Ugo?
let's get through this. I'm gonna
On
unassign.
the videos, Rodney, we see the closed caption.
Yeah, on the videos, I know you do. I'm gonna unassign her, because right now
Thanks,
your
Rodney.
your
I'm sorry.
Your CC is up. So let's do
We try one more time, thank you.
and captions, trade, captions,
Oh, there it is.
okay, so
Thank you.
you're welcome. You're welcome. So how did you guys like that? How'd you guys like that?
I liked it, but then one of my classmates dipped out.
Oh yeah, he didn't mean to. Who was that? Was that Armando?
Yeah, well, we got through it. though.
Armando, you left Aurelio. It was like you hurt his feelings. He didn't do it on purpose.
Hugo and I got it, so we're good.
Good. So, all right. So, let's just start with what I asked you for. Breakout room 1. Did you got somebody be the spokesperson there and tell me the 3 things?
Was that us? Oh, okay. So yeah, we were just talking about I've never seen the hydronic perimeter heating system, and then we talked about having it there, and if someone wasn't alerted that it was there, and then you went off and like fixed a piece of baseboard or something, you might end up hitting a line. Hugo also said that using that system up in the attic would probably be better, since if there was a leak, it would show on the ceiling and you could get to it and fix it faster. Another one of the things that we talked about and we thought was pretty interesting was the air exchangers, on how this appliance uses the warm air inside, and it kind of warms up the air that's coming in, so that kind of saves energy and it works more efficient.
So, pretty interesting. All 3 interesting things and new, right? New stuff that
Yeah,
you guys have done before. And you guys, Aurelio, you guys won? Were you group 1?
I just went with it, we're one, I guess.
Might have been 3. I think you might have been 3. Who was?
All right.
I can't remember anymore. I can't believe it.
I know. I just,
Okay, somebody else in another group. Who's gonna do those 3? And I guess John, no, you were 3. So Aurelio, yeah, you were 1.
We'll have Brenda do number 2.
Oh, thanks.
Okay, Brenda, what did you guys come up with?
I'm a girl. Okay, so the hydronic radiant heating system with the tubing and below subfloor. We thought that was really interesting. I know I used to watch the show Home Time years ago, and I believe that was in Minnesota, and that was the first time I ever was aware of this particular heating system. And they say that's a more comfortable heating system, and so I was like, ever since I've seen that, I've always wanted it, and of course I don't have that. Here we're slab on grade, and so we have the central heating and air. And then the second one we were talking about was the like Aurelio said about the how the air is heated and then cooled. We just thought, how in the world does that happen? It's like how it can pass through the heat exchangers and get warmed, and then it then cools the air, you know, and also wondering about the condensation, how you were talking about it can go into the waste, but then you see the drips outside, like on our home, we see the drips outside, on our RV, you know, of course your vehicle. But so does that mean you don't have the waste, or you also have the waste, it go into the waste and exterior?
Okay, so on an RV, like my RV and your RV, on all those air conditioning systems, all air conditioners, condensers, condense air, and so the water is a byproduct. So yeah, so there's always condensed air, air vapor turned into water on all those units, and as long as they're dumped to the outside, that's all we care about in RVs. They come down, hit our gutters, and go outside. In houses, you can't just dump them. They don't want you dump them willy-nilly to the outside. They want you dumping them in a place they know they're going to go, which is the sanitary waste. So inside a house, that's the difference, right? Is you got to dump your condensation to a sanitary waste. In RVs, you got to dump to the exterior.
Well, up here where we live, the 3 different homes we've lived in up here, we have the dripping out back.
Yeah. Well, is that from a central air conditioning system or window
Yes.
air conditioners?
Central.
Huh, okay, so at some point they did that, maybe, because today we can't do that. So maybe in those days codes, you were able to do that. And like window air conditioners, those just drip outside.
Yeah. Well, this house was built in 2006, so I don't know if that would have been passed
Yeah,
after.
that's 15 years. Lots happened in
Yeah.
15 years. So it could
Yeah.
very well be, and I'm assigning you to find out. What was your third thing?
Okay, and our third thing, we were talking about the first law of thermodynamics. Of course, Jose looked that up, and so he found on Wikipedia that it said when energy passes into or out of a system, which as work, heat, or matter, the system's internal energy changes in accordance with the law of conservation of energy.
Okay, so your other assignment for next week is to break that down into layman's terms that we can all understand.
Darn you, Jose.
Yeah, now who was it 3? Cesar, that group you were in?
Yeah.
You guys are 3. What did you guys come up with?
For our first one, we were surprised at what a big difference there was between the conventional heaters that are around 80%.
Yeah.
And the high efficiency heaters that were 96% plus.
Yeah.
And we're amazed at what a difference that was. It's almost a 20% difference.
Yeah, huge. Well, and also think about 300 degrees Fahrenheit exhausted air versus 100 degrees Fahrenheit, which is 1.4 degrees above your body temperature versus 300 degrees. You don't want to be touching that. So that alone is just like, wow, really? And this is one of those things that most people don't know. What's your second and third?
So my second one is that we were looking at the difference between ERVs and HRVs, and the ERV is able to provide fresh air from outside, unlike the HRV though, it has a dehumidifier, so it can bring in the air at the proper humidity, not just closer to the proper temperature. So if you live in Florida or something and you're exchanging air, you're bringing in that hot, humid air, you can take the humidity out of it and have it at the right temperature.
Which if you live in Florida, you better get the humidity out of it.
And then the third one we talked about is the efficiency increases in just having a programmable thermostat or a smart thermostat even further, and just using the heat and cold when necessary.
That's a really good idea. Yeah, we could do a class on thermostats and on programming thermostats easily, and I'm sure there are classes just on that. But I was thinking out loud, now I'm thinking out loud, but thinking about my house, because it's been cold enough, right? My wife and I have a cottage out back, which is our master. And so when we stay in our house, we exit, I turn off the heater. I have a wireless thermostat. I turn it off. And then we go out and we heat our cottage and we let it heat up. And in the morning, I come in and the heater hasn't been on, and I fire it up, and it starts heating. Am I using more gas? Would I be using less gas if I just kept it at 66 all night? So it came on a little bit at a time and it had less to heat up, and I came in, it was a nice comfortable 66 and I could crank it up to 70 rather than some mornings it's 57. This morning it was 60. Yesterday it was 58. So I just wonder about that. Anybody have any feedback or want to chime in or have an opinion about that?
I feel like you would be pretty close if you just left it. I feel like
Was
you're
it using about the same amount of energy?
Yeah, I think your system is working a lot harder in the mornings since it's so cold. It's going full blast to where if you were just to keep it at a certain temperature, it's just like you said, it's going to kick on maybe 25% just to keep it at that temperature, and then it eventually be out the same energy used to get your house to where you want it.
It might be less wear and tear on the unit as well.
Yeah, that's a good point. And I might, to prove it, I might just simply take a time slot that my gas bill is billed in, and go the whole time I'll do it this way, and then leaving it on at 66 at night or 65, and then just check out what it costs. How many?
You'll have to let us know.
How many therms? Yeah, I'll let you know. And I bet it's more efficient to keep it programmed. But this whole idea, like my in-laws live in Wichita, Kansas, right? So their heater is on all the time in the winter, and their air conditioner is on all the time in the summer. This isn't like, should we turn the heater on? Or should we turn the AC on?
That's a life or death.
All day and all night. So programming your thermostat to come on at certain times and go off at certain times where you're sleeping and you're not walking around is really a pretty good way to go. And okay, so somebody's got to leave. Appointment at 12:30. Student. Somebody. Good point. Anyway. Somebody's got to leave. Sorry about that. I still want to show you some videos, but I'm not going to because I had told you 9 to 12. So I will stop the class, and next week we'll see those. I got a couple of sewer things to show you, some what happens to older pipe, and then this really interesting job that I filmed. I've got a fair amount of footage, and a really good friend of mine building a unbelievable house. So we're going to see some unbelievably cool architectural and mechanical and structural details. It's going to blow your mind. It's really going to be fun. And in the meantime, you guys are having a midterm, right? You're having a midterm. So Jim's class, you're having a midterm. I think you're going to have class, if I remember what Jim told me, and then you're going to have a window after that to do a couple 2 or 3 day window to do your midterm. And I'll include, guaranteed, there'll be at least one question on what we went over today, and probably 1 or 2 cherry-picked questions from our labs before. Something, if you came to the lab, hopefully you'll definitely get it or have a way of finding it. Because see, I don't believe in cheating. And it's true. That's not true. I believe that you can cheat. But in terms of like tests, the whole thing about tests is my tests are open book. You can access the Canvas shell. You can go back to Zoom meetings, because the thing of it is if you don't have it in your head, I want you to find the answer. So if you're not retaining the information, that's okay. You can't retain it all. But if you want to learn the information and you get tested or get a question, then I want you to be able to go and find it, because that's a primo way to learn. As a matter of fact, personally, I think that's one of the better ways to learn. So if you're getting tested in my test, in my class, and I think Jim is this way too, find the answer, man. Find the answer with your phone, Google it, look in the book, but find it. So you really can't cheat. And even if you go ask somebody in class, you're using your mind to find out the answer. I'm not encouraging that. I think that's borderline cheating, but I won't be smacking anybody's hands with a ruler. So I'll see you all next Saturday. It's been an absolute pleasure as usual. And yeah, that's it, huh? Breakout rooms. I'm totally digging breakout rooms. We're going to do more breakout rooms. And Linda, we have you to thank for that. You're not here, but thank you. She suggested it, and I think it's just a great.
I liked it.
You did.
I thought it was cool too. Yeah.
Good. Good. I'm glad. I thought you guys did. Just in dropping in, it felt like there was some dialogue happening, and it made me feel good because that's, you know, we want to stimulate each other, right? And also it's nice for me not to have to like talk for 3 bleeding hours.
Yeah. By the way, Rodney, Greg Van Sant said hello.
Oh yeah, he's a great guy. You know him?
He was over at one of the job sites doing some work for the company I work for. And
Yeah. Who are you working for?
I work for Elliott and Poles.
Yeah. That guy's been around forever. But Greg Van Sand's a great engineer, man, and a really good man. He's his friend. I've known him a long time.
Well, I liked his car, and then it went on from there.
Totally primo car, man. So y'all, all of y'all, until next time, be safe, be careful out there. And just to reiterate, you know, if you need to talk to me or want to talk to me, text me, call me. You have my numbers, you have my email addresses, both pipeline and personal. So be in touch, okay?
All right, you take care of yourself. Thank you, Rodney.
Thank you, Rodney.
See ya.
Ciao.
Thank you. Take care.
You too.